Hi guys, this is Unit 6, Lesson 6. This is all about residuals. And we get to start with some silliness. This right here is a whole big part of our lesson, and it will now represent the equation of the line of best fit. It is pronounced y hat. Yes, y hat. That's like the official real math term, not just something I made up, which makes me so happy. Okay, that's all. We can move on now. A residual is the vertical distance between a data point and the line of best fit, the result of subtracting the predicted y value from the actual y value. A positive result means the actual value is above the line. A negative residual means that the actual value is below the line. They help us understand how well our model fits the data and identify any unusual data points. Look, I'm bored already. To find the residual, the formula is residual equals y minus y hat, where y is the actual value and y hat is the predicted value. You need that formula in your notes. I actually have a notebook now, and I just put that in my notebook. Okay, here's example number 1. The equation of the line of best fit for predicting sunflower height based on hours of sunlight is y hat is equal to 2x plus 10, where x represents the hours of sunlight and y hat represents the predicted height of the sunflower. One sunflower that was in the sun for 9 hours grew to be 26 inches tall. What is the residual of that sunflower? So if you remember, we just wrote down the formula for residual. Residual equals y minus y hat, where y is the actual value and y hat is the predicted value. I'm having a hard time speaking. So first find the predicted value of a sunflower that is in the sun for 9 hours by using the line of best fit and substituting 9 for x. Let me go ahead and grab something to write with. So we're going to use our formula that's right here, and we're going to substitute 9 for x. So we have y hat, which is our line of best fit, is equal to 2 times x, which in this case is 9, plus 10, okay? Which is going to give us 18 plus 10, which is going to give us 28. So our predicted value for y for this particular sunflower is 28, okay? Next, subtract the predicted value from the actual value. So we know that it was actually 26 inches tall, and our formula is actual value, which is 26, minus our predicted value, which was 28. Okay, and this is going to give us our residual. So our residual is going to be negative 2. A negative residual tells us that the sunflower is shorter than predicted. So the line of best fit is going to be something like this, and we expect it to be right here, but it actually grew to be underneath that. Okay, that's what it would look like. Guess what? I screwed up already. Let's try this again. A group of students are trying to find the average time to clean dishes. The variable x represents the number of dishes, so this is x, okay? And y represents the time to clean the dishes in minutes. This is y. Okay. Find the predicted value for each data point using the line of best fit, and there's our formula. So this one is going to be y hat. That's our predicted time. Okay. So what we need to do is take x, plug it into this formula, and solve to get y hat. Does that make sense? Okay. So we have y hat is equal to 3/4 times our first x, which is 1, is plus 1. Okay, so that's just going to give us 3/4 plus 1, which is going to give us 1 3/4. Now because I messed up, I know they went to decimals, so this is going to be 1.75. Okay, let's do the next one. Now we have 3/4 times 2, and guess what I need? My calculator, because I don't do this. 0.75 times 2 gives us 1.5. 1.5 plus 1 is going to be 2.5. Okay. And you're going to continue this all the way down the chart, okay? That gives us all of these values, okay? Now it wants us to find the residual values, which is y minus y hat. This one is y, and these are our y hat values, okay? So 3 minus 1.75 is going to be, dude, I'm not even going to, dude, it's too early in the morning. 3 minus 1.75, I could do this in my head, but I don't want to. This one's 1.25. This one's 0.5. this is negative 1.5. 6 minus 6.25 is negative 0.25. And this is 0.5. Okay, we're just subtracting 3 minus, 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 and it gives us those for our residual values. Okay. Here is example number 2. Graph the residuals between the height and weight of several adult kangaroos when the line of best fit is y hat equals 48x minus 125. Okay, so first find the predicted value for each data point using the line of best fit. So they want us to take this formula and plug x into it. Okay, so x is going to be, we can look right here on the chart and see that x is going to be height. So this has to be x, this has to be y, and they want us to find our y hat values. So what we're going to do is we go y hat is equal to 48 times our first x value, which is 4.7, minus 125. Okay, let's grab our calculator. We have 48 times 4.7 gives us 225.6. Subtract 125 and it gives us 100.6. Okay, we'll do another one so that you can see how I'm doing this. Y hat is equal to just our formula that's right here, 48 times x. Our next x is 4.9. I'm getting that from the table right here, minus 125. Okay, so let's grab our calculator. We have 48 times 4.9 gives us 235.2, minus 125 gives us 110.2. You would follow those same steps for the rest of the table all the way down, okay, and it gives us these values. Then we need to find the residual for each value. So we're going to take y minus y hat, so we're just subtracting straight across between these two columns. That's all we're doing. So 100 minus 100.6 is going to give us negative 0.6. 109 minus 110.2, I'm not going to try. Calculator, 109 minus 110.2 gives us negative 1.2. Okay, and you're going to do this all the way down, okay, which is going to give you these values. And then we're going to graph the residuals between the height and weight of several adult kangaroos using that line of best fit. So now they made a new graph right here. I'm going to blow this up a little bit so that you can see it better. Okay, so they just took the information in this table that you can't see now and they just graphed the data points. That's all they did. Okay, so a residual plot uses the same x values as the original data. So it's the same x values as in the first table. They didn't go like 4.7 and 6. Well, this is the x value. They took this column and this column. They got rid of these middle two. Okay, so they took the original x value and now our residual value. So 4.7 and negative 0.6. So 4.7 right there. There's that point. Okay, and they just graphed them on here. Okay. So this is what a residual plot looks like, and it's always going to be graphed around this x-axis, okay? This is going to be like your balancing point or whatever. It's always going to, you're always going to have like the positive and the negative. You're going to have these two quadrants, okay? Here is example number 3. A group of meteorologists took measurements from a hurricane over several days as it developed. The variable x represents the air pressure in millibars, and y represents the maximum sustained wind speed in knots. Graph the residuals when the line of best fit is blah. Okay, so the first thing we're going to do is find the predicted value for each data point using the line of best fit. So we have our x, we have our y, and we need to find our y hat. And we do that by taking our x value and plugging it into this formula. So for example, we would have y hat is equal to negative 1.17 times our first x value, which is 921, plus 1207. Sorry, I'm running out of room, so we're going crooked. Grab our calculator, and we'd go negative 1.17 times 921 will give us a negative 1077.57, and we're going to add 1207 to that, and our final answer is 2284.57. 2284.57, and it didn't tell us how far to round it, so we'll see on the next slide. I'm guessing it'll be a whole number for this one. Do the same steps all the way down there. Okay. Oh my goodness. Now how did we end up? I think I did my math wrong. Let's try this again. Calculator, come back. Oh, I added it. Okay. So we have negative 1.17 times 921 gives us negative. Oh my gosh, now I'm adding. I can do this, guys. I can. Okay, negative 1.17 times 921 gives us 1077.57. And then we need to take that, because see, here's my problem. It's not negative on my thing. So we're going to go 2284.57 minus, and now I don't have that other number. I'm sorry, I'm using a junk calculator. 921 times 1.17 gives us 1077.57. Come back, thing. 1077.57. This is a negative, and then we need to add this to it. So the way I have to do it on my calculator, because my calculator doesn't do negatives, is 2284. Nope. Sorry. 1207 minus 1077.57. Okay. Our real answer is 129.43. I can do this. I can. I have a brain. Okay, there we go. Do that all the way down. Now that you've done that, you need to find the residual for each data point. So we're just going to subtract y from y hat. Y minus y hat. Okay, 131 minus 129.43. We are definitely using the calculator, because even with the calculator, I'm failing. Gives us 1.57. Okay. You do that all the way down, your whole chart, okay? And then you're going to take your x values and your residuals, okay? And you're going to graph those on a new graph, and this is your residual plot for the data. All right? Here's question 1. This one is all you. A scorekeeper kept track of how many minutes players were in the game at a recent high school basketball game, as well as how many points they scored. The line of best fit is determined as follows. So here's your formula. And what they want to know is, let me go peek. Okay, they didn't really ask a question, but you're going to do what you asked before, what we've been doing before. So we have x, we have y. You would find the values for y hat, but here they are. Okay, I'm not going to make you do that right now. Now they want you to find the residuals, okay? So go ahead and do that. All right, to find the residuals, we're just going to subtract straight across, and my eyes are bad, so if I read these numbers wrong and, you know, look like an idiot, don't be surprised, okay? So I think this is 16. I don't know if it's 16 or 18. We're going to say it's 16 minus 15.76 is going to give us 0.24. Okay. 13, come back, calculator, minus 21.15 will give us negative 8.15. Okay. And then we've got 2 minus 0.36 gives us 1.64. 4. I'm not going to make you sit through me figuring out the rest of these, because it's just basic subtraction all the way down, okay? It does not ask you to on this question, but if you were going to create a residual plot, you would take your x values right here and your residual values and use them. So you'd have a point at 28, 0.24. You'd use these as the y values, okay, when you're plotting. Here is question number 2. A group of students are trying to find the average time to clean dishes. The variable x represents the number of dishes, and y represents the time to clean the dishes in minutes. Select the residual plot for the data. So pause it, figure it out, and come back. So remember, the columns we're using for the plot points are the outside two. So we should have a plot point at 1 and 1.25. So we should have 1, 1.25. This one's out. Let's get my black one. This one's gone. 1, 1.25. That one works so far. 2 and 0.5. That one's still working. 6 and negative 1.5. That one's still working. 7 and 0.25. Yep. 10 and 0.5. This is going to be our correct one. Okay. This one doesn't have any negative values, and we have 2 negative values on our table, and this one doesn't have any negative values, and we have 2 negative values on our table. So that's your correct graph. Here's practice question number 1 at the end of the lesson. Find the residual value that would need to be plotted if the y value is 195 and the y hat value is 192. Pause it, figure it out, come back. Remember, the residual formula is y, which is 195, minus y hat, which is 192. So our residual value for this one is going to be 3. Here's practice question number 2. The line of best fit is y hat is equal to 5.6x plus 53.7. A data point in the scatter plot is 790. What is the y hat value? Enter your answer to the nearest tenth. Okay, so pause it, figure it out, come back. What we're going to do is take our lovely little formula right here, and we're going to substitute our x value into the formula. So we have y hat is equal to 5.6 times 7 plus 53.7. Grab our calculator. 5.6 times, oops, not divided, times 7 is 39.2 plus 53.7 gives us 92.9. So that means our predicted value is 92.9 and our actual value was 90. Okay, here's quick check question number 1. What value point would you graph for residual at a height of 6.08 given the data in the table? How you would solve this is, it wants to know our residual value. Our residual would be the 4th column over here, okay? For the height 6.08, so we're dealing with this one right here, given the data in the table, okay? So we know this is x, this is y hat, it gave us y hat, okay? Now we need to find out the residual. And how do you find the residual? You subtract y and y hat. So it's just 185 minus 199.4, and then you'd select the correct answer. Here's quick check question number 2. The line of best fit is y hat is equal to 142.2x minus 11,156. This line shows the comparison of house size in comparison to the cost of the house. If the size of the house, 1,800 square feet, gives the cost of $250,000, what is the y hat value given the line of best fit? Okay, so we know that we have 2 data points here. We have 1,800 and 250,000. Okay, so those are going to be our x, y coordinates. We just need to make sure that we've got x and y in the correct order. Okay. So the x is always the constant, the thing that doesn't change, and the y is the thing that does change. So house values, this is going to be money down here, because money just goes up at a steady rate no matter what, okay? And this is going to be square feet, because, well, they both just go up steadily. Interesting. How do we solve this? The size of the house is 1,800 square feet. The comparison of house size in comparison to the cost. I think it's opposite. I think it's the other way. So I think our x values are going to be square feet. So square feet would be x, which is 1,800. And then cost would be 250,000. Yes, this is correct. I know this is correct. You can actually trust me on this. Okay, so here's our xy coordinates. What you're going to do is you're going to take your x value, which is right here, plug it into this formula, and find out what our y hat value would be, our predicted y value, and then select it over here. Okay, let's talk about how to interpret a residual plot. First, you locate the line where the residual equals 0 in the residual plot. It does not tell you this until much later in the lesson, which is stupid, but this is the x-axis. Okay, it's that simple. They try to, like, I don't know, again, math brain people, they assume you know this, but they don't tell you until later in the lesson. So find the x-axis. Notice the points graphed in the plot. Do the points have a pattern, and are the points randomly above and below the line where the residual equals 0, which is the x-axis? Okay. Does it have a pattern or is it random? That's your first question. If the points show no pattern, then you can conclude that the linear model, the line of best fit, is an appropriate model. We want random. Random is a good thing. If the points form a curved pattern, if you can see a pattern, then you conclude that the linear model is not appropriate for the data, and a non-linear model, such as quadratic or exponential, may be a better fit. So if it has a pattern, it's not a good thing. We want random, okay? So if you look here, these are examples. This is a random pattern. We could not draw one line through this and have it make a pattern. We could draw like 3 lines, but that's not what we're after, okay? This obviously has a pattern. This is a parabola. This is a parabola. It could also be exponential. It could just be like a scoop, okay? But anything that you could draw a line through is going to be linear, and it's not what we're after. We're looking for random, okay? Here's a check-in. Determine whether each statement about the residual plot is true. If the residuals are randomly scattered around the line where residual equals 0, the x-axis, that's the only place it tells you that, for the entire data set, then the linear model that was used is reliable. So if it's random, is it reliable? Yes, that's our correct answer. A residual plot that shows residuals forming a wave-like pattern, that is a pattern, indicates that a nonlinear model might be more appropriate. Okay, this one is also true. A residual plot that shows a curved pattern indicates that the linear model used is reliable. Nope. If it has a pattern, it's not reliable. A residual plot that shows residuals forming a U shape suggests that a quadratic model might be more appropriate. Bingo. Okay. True, true, false, true. Checking the residuals for your data. This is very important to ensuring that you have accurate data. If you make a residual plot and it has a pattern, then you did something wrong. This is not a good residual plot, okay? It's a rather simple process. If the residuals are equally and randomly spaced about the line where residual equals x, the x-axis, then the linear regression model is a good fit and will allow you to make accurate predictions for the data. You should not be able to predict residual values. Okay, residuals should be random. If you can predict them, then it's not good. Okay, that's not random. That's not what we're after. There's a pattern that you missed somewhere. So here's example 1. Imagine you're a researcher studying the relationship between the number of hours students study per week and their exam scores. You collect data from a group of students and use linear regression to create a model that predicts exam scores based on study hours. After fitting the linear model, you create a residual plot with the fitted values, predicted exam scores on the horizontal axis, and the residuals, differences between actual and predicted scores, on the vertical axis. When you examine the residual plot, you notice that the residuals form a U shape. You can see that right there, okay? Is the linear model that was created for predicting students' exam scores reliable based on this residual plot? Is this reliable? No. The given residual plot clearly has a pattern. Therefore, a linear model is not reliable and will not provide accurate predictions for the original data. Here's example 2. A nutritionist is studying the relationship between the number of calories consumed per day and weight gain over a month in a group of individuals. They collect data on the daily calorie intake and the corresponding weight gain for each individual over a month. Then they use linear regression to create a model that predicts weight gain based on daily calorie intake. After fitting the linear model, they create a residual plot with the fitted values, predicted weight gain on the horizontal axis, and the residuals, differences between actual and predicted weight gain on the vertical axis. Determine the reliability of the linear model given this residual plot. Is the linear model that was created for predicting weight gain based on calories consumed reliable based on this residual plot? Is this reliable? Yes, the given residual plot does not have a pattern. The residuals are equally and randomly spaced around the line where the residual equals 0, the x-axis. Therefore, the linear regression model is reliable and a good choice for this data and will be accurate when making predictions. Check in. After examining a residual plot, Kai determines that his linear model should not be used to make predictions. What might Kai have noticed in the residual plot? Explain. Kai must have noticed that the residuals did not appear random in the residual plot. In other words, there must have been a pattern to the residuals in the residual plot. If the residuals in the residual plot are not random, then the linear model was not reliable and should not be used to make predictions. Okay, your turn. This is question 1. An environmental scientist is studying the relationship between the amounts of fertilizer used and the yield of crop in a series of agricultural experiments. They collect data on various amounts of fertilizer applied and the corresponding crop yields. Then they use linear regression to create a model that predicts crop yield based on the amount of fertilizer used. After fitting the linear model, they create a residual plot with the fitted values, predicted crop yield on the horizontal axis, and the residuals, differences between actual and predicted crop yields on the vertical axis. Is the linear model that was created for predicting crop yield based on amounts of fertilizer reliable based on this residual plot? Hey, guess what? You didn't need to read any of these 2 paragraphs. You just needed to look at the question and look at the graph. Is this reliable? No. An upside-down U-shaped pattern in the residual plot suggests that the linear model is not capturing the true relationship between fertilizer use and crop yield. This indicates that the relationship might be quadratic rather than linear. In other words, the effect of fertilizer on crop yield may increase up to a certain point and then decrease, suggesting that there is an optimal amount of fertilizer beyond which the yield starts to decline. Here's question number 2. You can read all of this garbage if you want to, but the question is the linear model that was created for predicting annual salary based on years of experience reliable? Is this reliable? Yes, the given residual plot is equally and randomly spaced around the line where residual equals 0, which is the x-axis. Therefore, the linear regression model is a good choice for this data and will be accurate when making predictions. Here's the end of the lesson. Practice question number 3. Determine the reliability of the linear model given the residual plot. Enter the number of the correct option. So first, look at it. Is it random or is there a pattern? Well, obviously, it's random. So this one says it has a pattern? Nope. You're gone. This one says it has a pattern? No, it doesn't. My dog farted and it smells so bad. The residual plot is equally and randomly distributed around the line where residual equals 0. Check. Therefore, the linear regression model is a good choice for this data and will provide accurate results when making predictions. Practice question number 4. Determine the reliability of the linear model given the residual plot. Let's look at this. Is there a pattern? Nope. So this one says it's equally and randomly distributed around the line. Yes. Therefore, it is a good choice for this data and will provide accurate results. Bingo, bango. Clearly has a pattern. No, it clearly does not. And this says it clearly has a pattern. You should always check all 3 answers, even if the first one is the correct one, because if you find another one that can work, then you need to double check. Here's quick check question number 3. Determine the reliability of the linear model given the residual plot, just like we've been doing. Does it have a pattern? And then eliminate. Check in. How do you determine a residual value? Residual is equal to y minus y hat. In other words, subtract the predicted value given by the line of best fit from the actual value. If the predicted value is greater than the actual value, then the residual will be negative and therefore an overestimation. If the predicted value is less than the actual value, then the residual will be positive and therefore an overestimation. Connecting a scatter plot to a residual plot. Analyze the scatter plot. How do the data points on the scatter plot relate to the line of best fit? How far are the data points from the line of best fit? Okay, so we're going to determine, does this line of best fit match this scatter plot? That's what we're working on in this section. The data within the scatter plot tends to be near the line of best fit. You can see that for this one. Everything is pretty close to the line. 3 of the actual values are slightly above the line of best fit. This one, and this one are all above. Okay. 1 of the actual values appears to be on or very near the line of best fit. This one. And 2 of the actual values are slightly below the line of best fit. This one and this one. This means that you should expect that on the residual plot. 3 points will be above the residual equals 0 line, or the x-axis. 1 point will be very near the residual equals 0 line, or the x-axis, and 2 points will be below the residual equals 0 line, or the x-axis. So this best fit line, when it's on this plot, is the same as the x-axis on the next plot. Okay. So if you see here, we've got 3 above, 1 really close to it, and 2 below. So this does connect to the first one. Okay. These are related. All right, let's go to the next. Here's a check-in. In general, when connecting a scatter plot to its residual plot, a point that is above the line of best fit will have a corresponding point above the residual equals 0 line on a residual plot. A point that is below the line of best fit will have a corresponding point below the residual equals 0 horizontal line on a residual plot. A point that is exactly on the line of best fit will have a corresponding point on the residual equals 0 horizontal line on a residual plot. If it's above on one, it will be above on another. If it's below, it'll be below. If it's on, it will be on. Okay. Here is example number 1. Which residual plot best represents the given scatter plots? So this is our original graph, and we need to see which one of these fits this. So regarding residual plot A, the majority of the data is below the line of best fit. You can see most of these points are under it. Out of the 6 data points, only 1 point is above the line of best fit. It appears that some of the points are on the line of best fit over here, but because of the large scale, it's hard to tell if they're just close to it or on it. Okay. Also, the x values of the data in the residual plot are between 4 and 7. You can see that everything's falling between 4 and 7. And here, everything's falling between 4 and 7. Okay. So let's look at B next. Regarding residual plot B, the majority of the data is above the line of best fit. Out of the 9 data points, only 2 points lie on the line of best fit. The x values of the data in the residual plot are between 5 and 40. Okay. This does not go clear up to 40. Given these descriptions, residual plot A best represents the given data, even though it may not be an exact match. Okay, so we can't really tell with these if they're exactly on. Like this one's probably under, this one's probably under this one. I don't know. Okay, so it's possible that when you zoom in, they could be under and above, but the range tells us that this one has to be it. This doesn't make any sense in connection to this graph. Here is question number 1. This is your turn. What does this residual plot tell us about the scatter plot? Let's look at this. So the scatter plot has 2 points above the line. That makes sense. Of best fit and 4 below. 1, 2, 3, 4. That is a possibility. The scatter plot, let me pull up my tools so I can cross out when I need to, looks the same as the residual plot. Do they look exactly the same? No, we saw that with the last one. Okay. The residual plot does not indicate anything about the scatter plot. No, they're connected. Come on now. The scatter plot has 3 points above the line of best fit. 1, 2, no. And 3 below, no. So it has to be our top one. Okay. Pachink. Here's question number 2. Imagine creating the residual plot that corresponds with the given scatter plot and line of best fit. Describe the shape of the residual plot. How many points will it contain? Where will the points be with respect to the residual line, residual equals 0 line? Pause it, figure it out, come back. The residual plot will contain 6 points because this scatter plot has 6 points. 3 points will be slightly above the residual equals 0 line. We have 1, 2, and probably this one, 3. 1 point will be on or very near the residual equals 0 line, which is this one. And 2 points will be slightly below the residual equals 0 line, this one and this one. The x values of the points on the residual plot will be between 2 and 10. Practice question at the end of the lesson. How many points would be below the residual equals 0 line in the residual plot of the function shown? So how many would be below? Not that one. Yes. Not that one, not that one, not that one. Yes. So 2. Quick check question number 4. Based on the scatter plot, connect the shape of the scatter plot to the accurate description of the shape of a residual plot. Which residual plot description is the most accurate? Okay, you can do this. It's going to tie to this. And based on the scatter plot, which residual plot description would be the best match? You can do this. I believe in you. So just so you know, all of the random pictures through here that had nothing to do with anything, I used the search term Milo because I wanted to do Pepper Ann, but it was all like the exact same red chili peppers.